We have a nice one, still on connected particle. This one says, a particle of mass m kilograms resting on a smooth table. So this one we are going to do as we sketch. So now, I start with it. A mass is resting on a smooth table. So I'm going to draw my table like this. It's going to be my table. This is going to be my table. Now they're telling me that a particle of mass m. So this is my table. So I have a particle of mass m. This one is having m kilograms. Two bodies of mass 4 kilograms and 8 kilograms attached to A from both sides by two strings passing over smooth pulleys at the edges of the table. So we have some pulleys at the edges of the table. So that is pulley 1. This is the second pulley. Now I think that there are strings passing over these two pulleys. Now, masses, these strings are holding some masses. So this one, masses of 4 kilograms. So this one is having 4 kilogram mass. And then this one is having 8 kilogram mass. Of course, it's bigger. 8 kilogram mass. So those are our. So A from both 4 kilograms and 8 kilograms attached to A from both sides, as you see, from both sides. The strings are taut. Taut means you cannot move. That string means that it's inelastic. That's what the word taut means. It's inelastic or inextensible. Taut, and the body released, and when the string released from rest, it accelerates. It moves with an acceleration of 1.5 meters per second. Find the tensions in the string and then the mass m. Of course, how this thing is going to move? Of course, it's going to move in direction because this one is weighter than this. So this one is going to move in this direction. So it means that our acceleration, which is 0.5, is going to be in that order. Of course, this one is pulling, so meaning everything is moving like this. So meaning this one is going to be moving 0.5. The acceleration is given here as a half. Okay. People may get lost. A half meters per second squared is equal to 0.5 meters per second squared. So that's what I'm using there. So then this one is moving up like this at 0.5. It should be the same. Acceleration acts in the same direction. So this is our acceleration, then our acceleration, like that in that order. Because they are in the same system, it means it's going to be the same. But because this one is moving pulled, so let us call this tension, it's going to be having T1, and then this one, let us call it, this spin is going to be having tension, we are calling T1. Why? Because the strings are different. Okay, so this one is also going to be having now T2 tension in that spring. T2, and this one is going to be also T2. I think you know why we are doing this. We say the tension, as this particle is being pulled down, there is this tension that is going to be acting opposite because of this force holding it, the same throughout. Because this is having mass, we expect a weight, which is the mass times the gravity. Then this one is going to be 8 times the gravity. That's how we get the weight. Because we say weight is equal to mass times v. So this one is going to have a weight of md, as simple as that. Of course, if this one is resting, it means that it's going to have a reaction. But this reaction is the same as that. Because the body is not moving vertically upwards, or it's not moving, so it's resting here, meaning this is equal to this. So vertically, the forces are equal. So after doing that, the rest I think is history. We just consider, let us have a 4 kilogram mass. Okay. Now if we have 4 kilograms, this is that our acceleration is in this direction. That's where our acceleration is. And you know that our resultant force is equal to the mass times acceleration. Because we say the resultant force is in the same direction as the acceleration. So you see that now if it's acceleration to this side, it means that even the resultant is on that side. So we get what is pulling this particle upwards there. It's going to be this T1, I think we see the arrow. So we have T1, then minus what is opposing it is 4g, equaling to the mass, which is 4 times the acceleration. Life is very easy. So this is 1. And we have this binary. This is very easy because we have our acceleration as 0.5. So RT1 is going to be 4g, then plus 4 into our acceleration, which is a half. So this would be, so RT1 is going to be 4g plus R2. Really easy. So I think we can easily press this on a calculator. So RT1 is going to be, okay, 4 into 9.8. 4 into 9.8, then plus 2. So RT1 is going to be, so my T1 here is going to be 41.2. Tension is measured in newtons because it's a force. When I come now, let us start with this one, the 8 kilogram mass. So you see where is it act? You see that the acceleration is going downwards. So it means that the resultant force is going to act downwards. So my FR should be equal to MA. Now what is pulling it downwards? When we have this force, what is pulling it downwards is 8D. What is opposing is T because for it is acting upwards. Equal to the mass, which is 8 times the acceleration, which is a half. So that now this will be 8 into 9.8, then minus T2 equaling to 4. When you simplify that, when you come this side, we have 8 times, which is 7, 8.4, then minus 4 to be giving us T2. So there our T2 is going to be 74.4. Now these are in newtons. You see, I know when you subtract before you get this, but please, if these things, press a calculator simply. Okay, when you come to the MKG, I think this question was the easiest. Okay, now you see, vertically, this is going to be equal to this because the body is not moving. But interested in this, so you see that our acceleration is going in this direction. When you know the direction of the acceleration, life is very easy. So what is pushing it in this direction? We have our resultant force to be equal to mass times the acceleration. So our resultant force, you see it's going in this direction. So T is pulling it there, then minus the opposer plus the outside dash. You know those? Anyway, mass is M, then times acceleration, which is a half. Okay, so our mass is that we are going to be adding, we have these two. So I have T2 as this T2 is 74.4, then minus T1, 41.2 equaling to M over 2. So when you simplify that, we have minus 41.2. We have 33.2 equaling to M over 2. Multiplied by 2. You see if you cross multiply, now our mass will be 66.4. Then this is 8 kilograms. And life is very easy. Easier than what you expect. So that's going to be our mass. As simple as that. So that's it, members. I wish you well. We are going to now some proofs. Let us see some proofs. Always see. Okay, anyway, we are going to see the next lesson. Don't forget to subscribe to the channel. See you there.